In previous lesson, we have learned about electronic configuration. The electronic configuration of an atom shows how electrons are filled in orbitals. It describes the arrangement of electrons in an atom. To be able to do that, we have to obey the following rules: Aufbau Principle, Pauli's Exclusion Principle, and Hoons Rule. Aufbau Principle states that electrons must occupy available orbitals of lower energy first before they fill orbitals of higher energy. This means that electrons should occupy the orbital with the lowest energy before it enters the ones with higher energy. The order of orbitals to be filled by electron is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Increasing order of energy of the orbitals is 1s is less than 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, and 6s. Order of orbitals to be filled can also be simplified by drawing arrows on the following diagram. Let's look at the example. Hydrogen has proton number equals to 1. So the SPDF notation for hydrogen is 1s1. The first electron must be placed at the 1s orbital, which is the lowest energy level. Helium has a proton number of 2. So the SPDF notation for helium is 1s2. The second electron still at 1s orbital. Lithium has proton number equals to 3. So the SPDF notation for lithium is 1s2, 2s1. The third electron is at 2s orbital. Pauli's exclusion principle. The principle states that no two electrons in an atom can have the same 4 quantum numbers. This means that they cannot have the same set of n, l, m, s. Since each orbital has different set of n, l, and m values, which determines its energy level, shape, and orientation in space, it follows that only orbital can hold a maximum of 2 electrons. Electrons in the same orbital may have the same value of n, l, m, but must have 2 different values of s, either negative half or positive half. Let's look at lithium. Lithium has proton number equals to 3. So the SPDF notation for lithium is 1s2, 2s1. From the orbital diagram, we can deduce the set of quantum number for each electron. Note that none of the electrons in the orbital has the same set of 4 quantum numbers. The last one is Hoons Rule. Hoons Rule states that when orbitals of equivalent energy or degenerate orbitals are available, electrons occupy these orbitals singly first, with the same spin before pairing up with opposite spin. Hoons rule is applied where orbitals of equal energy or degenerate orbital are available. For example, 2px, 2py, and 2pz. Each of these orbitals will first fill with one electron with parallel spins before a second electron is added with one opposite spin. Example, carbon, proton number equals to 6. So the SPDF notation is 1s2, 2s2, 2p2. Nitrogen, proton number equals to 7. The SPDF notation is 1s2, 2s2, 2p3. Oxygen, proton number equals to 8. The electronic configuration is 1s2, 2s2, 2p4. The 8 electron is paired up with electron of the opposing spin in 2px orbital. For fluorine, proton number equals to 9. So the SPDF notation is 1s2, 2s2, 2p5.